pop, right?
Yeah.
Correct? So, I'll do the two steps, okay, to make it easy for you. I can pop and print here. Right? Let's say I don't pop anything here, just for a sec. I'm gonna come in without. And here I wanna print all of them. Right? What will I print?
You should do the so it'll be 7.
From top to bottom, 2417.
No, it'd be 7142.
What the?
This is coming from here, don't worry about it.
Oh, that's right, it goes the other way around.
Comment this out so you're not confused. Right? I will first pop 7, then I'll pop 1, then I'll pop 4, and then I'll pop 2. Right?
Oh,
Now
that's
this
right,
stack
you
is
do it backwards.
empty, right? Now this stack is empty, right?
You do the first.
Is that clear? One exercise that is a nice exercise, I will issue in a second, but I want you to see exercises from previous again.
Okay.
Professor,
Yes.
so usually when you do like a print, you would always make it pop so you lose all the elements after? Or do you, like normally would you have a print, like print all where you just print it but you keep everything inside it?
You cannot. You cannot print all the elements in a stack without popping them. How could you do that? Just giving you an idea.
You
What
can make
you
a
could do-
temp variable, right?
Or the array maybe, where you pop, you put it there, and then you put it back. That's something you can do.
But yeah, but that's what I'm saying. Would you usually, is that how you implement it?
Yeah.
You just pop it, right?
Just popping, there's no other way.
Okay.
Because if you start manipulating the array to do a for looping stack, you're breaking the concept of a stack. Right?
Right, that's what I want to know. That's the main concept. Okay.
Then you break the concept of a stack. This is a boring part we put in a counter, right? I don't want to let you do it.
Turn off the monitor.
Yes, we should be. Actually, you're right. You're right. Thank you very much. Makes my life so much easier, right? Okay, look at the first question. That's pretty easy, right? Do you get to read it? Read a little bit. Better? Yeah. So very well. Okay, guys. Don't get scared. Don't get scared of the big name university. The concept is the same everywhere. The concept is exactly the same everywhere. Okay. We get a big string that says easy question. And it says it's going to be a stack. And every time you find a letter, it's going to represent, it says a push. And every time you find a star, it means that you have to pop. And then it tell me, give the sequence of values returned by the pop operations. So every time we have a star, we're going to pop something, right? We have to say what's going to be what we are printing. Make sense? Okay, we play with a stack. It's not telling us how big the stack is, so let's play with the stack like that. We don't care about size now. So we have an E. We push it, right? And then? Then? And up. Now this is your first sequence, right? This is part of your first sequence, right?
Pop Y.
And then you push Y,
Pop Y.
pop Y,
Put Q,
Q, U,
E, pop E, pop U, and pop Q. Put S, put T, take away T, take away E, oh, that's S, I'm sorry, S, take away A, and replace A with I, now O, now take away O, and put N,
and then put N, right?
put N where the O was.
Okay.
Sorry, all three of them. N, take away N, I,
There's
E.
no A, it's E. I'm sorry, you misspelled one of it. Instead of A, it's an E.
Here?
Yes, there's no A in there.
My bad.
Oh, sorry.
Okay. How hard was that?
I didn't spell any of it.
This got my finger red. How hard is that?
Hard.
Hard?
No.
No? Fake, right? Fake.
Make sure that's on your final.
Huh?
Make sure that's on your final.
This is funny, you say, this is funny what you're saying, because you said, it would be nice if you were in the final, right? And then if I tell you I'm going to put a question from Princeton, all of you are being your fans, right? Some of you are. Right? Just hearing the name is like, oh, okay,
Some of them
sorry.
may be in the computer for
We don't have this problem, so. Look, modify the stack drawing to issue a warning is applying a test pop and an empty stack or push and so forth. We have already done that, right? How hard is that? And I'm not lying to you guys, it's Princeton here, you see? Okay, 5 for this is a Q, so we're not doing Q's now.
Number 7.
Okay. I'll change this to make it a little more complex, because this is too easy.
Yeah, that's what it
Let me change that to make it a little more complex. Given a string, play with the stack to reverse a string. Okay? So if you enter your name Joel, like that, right? So it should print something like L-E Leoy, right? Make sense? That would be that. It would be S, my original string, is 1. Let's say it says 2, my reverse string. How can we do that?
You just do the RN and push, push, push.
Okay, let me create a stack. You want me to code it or do it here? I'll code it. Can I do it on the board so you guys do it? Okay.
Already,
You
just
understand that if I
push
do
the
this problem,
thing
I'll
the
put
way
something
you
harder than
follow
that, right?
No,
this is the program. Do it just.
We understand it.
It's funny, I kind of get it now.
Yeah, when you get home.
Wait, what type is it?
Now, the problem is that my stack is not of characters, my stack is of integers, right? Huh? Is it too hard to change that? Is it hard to change stack from integers to stacks of Qs? I can play with the integers, the stacks with the characters as integers, right? Because every character is an ASCII, right?
Alright.
I can play like that too. That shouldn't be a problem. Let's do like that, so to make it more complex.
I hate that shit.
Otherwise, it looks too
I can
easy,
memorize
guys. I
it
want to
so
play with
much,
that.
you know. Who uses that?
Size, capacity.
So let's play with the stack of size 10. That should make to be safe. UL is smaller than 10. That's still fine. So what I'm going to do is go for every position from the string of UL. Right? For every character. Right? Obtain a character.
char.
I can make char, or I can, yeah, char C equal S1, that's char at I, right? And then push that into my stack. I'm gonna push C. So what am I doing? I'm taking UL and pushing Y, but as an integer, right? Because it's a stack of integers. So I'm not pushing really Y, I'm pushing the ASCII of Y. Let's say it's 104, just to make a number. Then I'm pushing O. Then I'm pushing E. Then I'm pushing L. What do I need to do now? Pop, and as I pop, put that in a string, or print it out, right? Just print it out, to put it all together, right? Let's say I just want to print the name, I don't want to form, I just want to print it. If I just want to print it, all I will do is say, wow, my stack 2 is not empty, right? Because I have to stop when it's empty, right? In n equal, right? My stack 2 plus pop. Now this thing is going to give me a character number, right? I want the char again, right? How do I recover the char? Not a problem. Right?
Yeah.
And then system that out. Not print line, just print because I want all the characters to come together.
Was that casting?
Yeah.
And print C, right? Let's see what we get. See? Le doy. Got it? Got it?
Oh, I see.
Got it, right? How much time to code this? Not even a minute, right? 2 minutes if you want. Okay, so in your final, you should expect something like this, or a little bit more fun, right?
Go ahead, clear my integers.
So,
Yeah.
got it? Yes?
I can bring a guide of what an ASCII is like. What that means.
I hope he doesn't use it.
Let's see if there is anything more interesting here.
Okay, you just do, yeah, just
Study those.
Okay. This is a very nice
What
drawing.
happened last time. Study those. Like,
Wow, I wish I had the time to do all of this. I'm gonna solve this one. But this one and this one and this one are too easy, so I'm gonna leave it for you. So, question number 8. Write a program that reads in a sequence of characters and determines whether it's, okay, put it simple. It's saying, if you have expression, such as this expression is considered balanced, because for every opening, you have a closing. Okay? But if I have an expression like this is unbalanced. Even if I have this is unbalanced. These two guys are good, but these guys don't have the closing. Got it? So what they are telling you is, use the help of a stack, okay, to determine, so you write a method that receives a string and returns true if it's balanced or false if it's not. Simple like that. How could I do that? What you could do is analyze the string, and as you see an opening guy, push it. And as you see a closing, pop. If at the end of everything, the stack is empty, it's balanced. Because that meant that every opening had a counterpart. Right? Is that clear? But if you end up with a stack that still has some elements there, means that these guys didn't have their closings. Therefore, you say false. How hard is that? I could code it, but I don't have time. I have to go to Q's today. Okay? You should do that in probably 5 minutes. Right? Pretty easy. I'm going to solve this in a sec. Add an interface function. Forget about it. Add a method called multipop that receives a parameter k that pops k elements from the stack or until the stack is empty. How hard is that? While counter is less than k, or is empty, or is not empty, pop, stack pop. That's it. How hard is that? Probably around 2 minutes to create that method. You understand what I'm saying, right?
Yeah.
Yes, all of you? And then show how to implement the QUs into a stat. Well, we haven't learned QUs yet, so we're going to revisit this website. So we're done with all brainstorm exercise. Yes. Have a question? I thought you were with your pen. Okay. Now let me show you how to convert from decimal to binary and how we can use stats for that. Okay, guys. So, how many of you know how to convert from decimal to binary? Just one? Two? Okay. If you have any number, okay, let's say 7, and you want to convert it to binary, there will be a million ways of solving it, okay? But I will show you the most straightforward one. This is called successive divisions, okay? And I know that some of you are used to dividing something like using this weird symbol, but I don't really care about that. I was taught this way. 7 divided by 2 is 3, remainder 1. Okay? That's weird, right? For some of you it's weird. That's the good way. But you understand this, right? This is basic division, right?
The worst.
So, now, why is this useful? Because this builds a nice ladder shape. You're going to see it now. That's how you learn in Cuba too, right? So, that's the good way. So you say you want to convert 7 to binary. So you said divide by 2. Binary is 2, right? 7 divided by 2, quotient, 3, right? Remainder, 3 times 2 is 6, remainder, 1. Now, you keep dividing. 3 divided by 2, 1. Remainder, 1. You see that I'm dividing the quotient every time, right? Now this is my last quotient, right? Divided by 2. 1 divided by 2 is 0, and remainder himself, because this is smaller already. When I get a quotient of 0, I stop. What's my binary number? It's going to be formed, building it vice versa. So 1, 1, 1. So all the remainders form my binary number. So 7 is equal to 1, 1, 1 in binary. Now, Professor, you're saying vice versa, but it looks to me like it doesn't really matter if it's that way. It does matter. For this number, it doesn't really matter because they're all ones. Have a question, Corey?
No, it's like, not like recursion again.
Yeah, you can do it with recursion actually. So, let's play with another number, say 4. Okay, 4 divided by 2. 4 divided by 2, 2, remainder, 0. 2 divided by 2, 1, remainder, 0. 1 divided by 2, 0, remainder himself. Right? So 4 is equal to 1, 0, 0. Okay? You learned the trick? Yes? How do we call this? Remember, classic approach that people take. I'll write the code. Right here. People say, when do I have to stop? Look, the number becomes its quotient, and eventually the number becomes 0. Correct? So that's why I have to stop, right? So, let's say I'm going to have a string S. Yeah. Doesn't really matter having a string S. What I'm going to say is, while the number, say n, is greater than 0, I have to keep playing, right? What is the first, what you have to print? All remainders, right? How do you print the remainder? Well, the remainder is n mod 2, right? Because you're doing it by 2, right? You print this remainder, r, right? And then you make n equal n divided by 2, because n becomes its quotient, right? That will be the code, right? Correct? But this code is not going to work. Maybe some of you cannot see it. That code is not going to work. Correct. This is what I wrote. Some sort of pseudocode, okay?
while n is more than 0, won't it like never stop? Because at the last part, it'll end being 1.
No, at the end, n becomes 0.
Oh, okay, I'm looking at that one.
Now, why would this not work? Because it gets the first remainder, 1 or 0 here, and it immediately prints out. So it's printing the number, vice versa. You understand what I'm saying?
Yep.
If I get the remainder and immediately print it, I'm printing from the first remainder all the way up to the last remainder. But the number is formed vice versa. Remember? The number is formed from the last remainder all the way to the first remainder, right?
Yeah.
So this will not work. This is printing the number vice versa. So how could we do it?
Push it backwards.
As we get a remainder, push it. Get another remainder, push it. When we finish pushing, when we have finished with the number, the stack contains all the digits of our thing. Just pop them out, and then we have it. Got it? How hard is that? Right? It never gets hard, guys.
Never.
Stats and Qs are actually the easiest topics. Let's say capacity 10. I don't really care.
How can I get to this thing?
So let's play
Oh,
with n
generic.
equals 4,
So
for
like
example.
friends
Convert
and
n to a
that's
binary. So I will do this while n is greater than 4, sorry, greater than 0. Right? I'm getting a remainder equal n mod 2. Right? Then I'm going to push it. The remainder. And now n should become the division, right? When I am done, I'll pop everything and print as I pop. Similar to here. Alright? While my stack 3 is not empty, print and we pop of it.
Oh, this is the main class.
Oh. Okay. Maybe I should put a system of green line before getting here because it's getting messed with the other. I'll put another little green line here just to make it look nice and separated from everybody else. Right there. 1, 0, 0. Got it? Here's Leo. Easier card, guys. Now, Josh, I answered your question, right? When can we use stacks? You've seen a bunch of applications, right? Clear, guys? Yes? Now you're masters of stats? You sure, right?